Welcome to the 30th lecture on numerical analysis. In the last couple of lectures, we have been studying Simpson's rule of numerical integration, and we studied Simpson's 1/3 rule and Simpson's 3/8 rule. This is a recap of the last couple of lectures, and we studied these formulas. These formulas are not new to you, and these formulas are inspired by the famous trapezoidal rule that we have also studied in this course, maybe 3 lectures or 4 lectures ago. Right, so in this lecture we are going to introduce to you a spreadsheet like Microsoft Excel or LibreOffice calculator, for example, a spreadsheet to compute these integrals, a definite integral using Simpson's rule. So we are going to develop a spreadsheet like this. This spreadsheet was prepared using LibreOffice calculator on Ubuntu, but you can use the same spreadsheet on Windows under Microsoft Excel. Right, so we start by introducing a and b, the upper and lower limits, like this, a and b, and then we introduce n in our spreadsheet, that is the number of subintervals, and I have fixed it to 6, and h is, this is b minus a divided by n. So this is b divided by a, b minus a divided by n, we studied earlier. So this is n, so this should be written as b minus a divided by this n. Right, so and the next is, since this spreadsheet only takes or only addresses the definite integrals that for which we have used Simpson's rule, and we have divided into 3, and we have divided those into 6 subintervals from x0 to x6. x0 is the start of the first interval and x6 is the end of the last interval. Right, and x0, what should be x0 then? It should of course be a. We studied that earlier. What is xn, the last? Of course this is b. And how do you calculate these intermediate subintervals? The limits of these intermediate subintervals, this is x0 plus this b7h, and the second interval, the limit for the second interval is this base value plus 2 times h, and we keep on going, 3 times h, 4 times h, 5 times h, and 6 times h, which is equal to b, the upper limit b. And then we are asked to compute f of x0, and that would depend on the actual f of x we are dealing with. Suppose we deal with the first example number 1. For this example, f of x is x squared. Right, so we should have this written as x squared. Right now it is exponential. Okay, let's change it, is equal to x0 squared raised to the 2. That is this. Right, and the limits are from 0 to 1. So from 0 to 1. Right, and to copy the same formula for all these cells, we just bring our mouse here unless it becomes a plus, and then we click and then drag it down the row, down the column along all rows, and it becomes this. So now we have this formula copied for all these cells. Right, the same formula copied for all these cells, and then comes this 1/3 and the 3/4 rule. Let's put it here. The 1/3 rule, the answer computed using 1/3 rule would be b7 divided by 3. b7 is h. h B7 is h divided by 3. You know the formula for 1/3 rule is h by 3 f of x naught plus 4 f of x1 plus 2 f of x2. All odd f of x's are multiplied by 4 and all even are multiplied by 2, except first and last, which are multiplied by 1. So we have h2, the first multiplied by 1, the second multiplied by 4, the third multiplied by 2, the fourth, then the next multiplied by 4, the next multiplied by 2, and the last multiplied by 1. So actually this line implements the Simpson's 1/3 rule, and it comes out to be 0.33. And using 3/8 rule, this formula is actually the formula we studied for 3/8 rule, this one, right? And using this, even this formula yields the same result, 0.333. So let's see what is the actual result. It's also 0.333. Amazing. So it gives you very good result with least computations. So the only thing that you have done right up till now is that you have changed these a and b values, and you have introduced a formula in only one cell, and then you copied that formula for all cells, and that's all, and you get the result, right? Let's check it for the second example I have prepared for you. Example number 2, that is x squared, but now the limits are 0 to 2. F of x is the same, but now the limits are 0 to 2. The answer should be 2.66. Let's see. 0 to 2. The formula f of x remains the same, and 2.66. Wow, you get the answer, 2.66. This one, right? Let's move on to the third example. So actually this spreadsheet is making calculations of Simpson's rule easier for you. So the only advantage of this spreadsheet is that it makes calculations easier for you, right? So example number 4, the next example is 1 over x, limits from 1 to 2, right? So limits are from 1 to 2, and the function isn't x squared, but it is 1 over x this time 1 divided by x, this one. And you just copy this formula for all these cells, and you get to the answer 0.693, the same answer produced by both rules, 0.693. Let's see what the exact answer is. Wow, it's also 0.693. So you reach to the same answer, right? Now let's move on to example number 5, where we have this 1 over x, f of x is the same, but now the limits are from 3 to 5. F of x is the same. You reach an answer 0.51 by both rules, 0.51, right? And the same answer we reach to by computing this integral using the usual way, 0.51, right? And then e to the x, f of x is now e to the x, and the limits are from 2 to 4, right? 2 to 4, and this is e to the x. This is, I think, it's exp to the x, this one, right? And you can copy this formula for all other cells, and you return answer 47.21. Let's see what the exact answer is. 47.209, exactly the same answer. So this spreadsheet makes life easier for you. It makes calculations easier. You can try any f of x, you can try any limits you want, and you can try many different integrals, and by the help of this spreadsheet you will reach to an answer within no time. Very instantly, very quickly you can reach to the answer, right? That's great. So now we have a small homework for you. Try different integrals from your FSC or A-level mathematics book and evaluate those integrals using the spreadsheet we have discussed in this lecture. I'll share this spreadsheet with you. I'll share this spreadsheet with you on WhatsApp, on our WhatsApp group. Right. That's all for this lecture. Thank you.